Okay, we're going to talk right now about section 2, defining general angles using radian measure. Okay, so the first thing we need to talk about is measuring angles in standard position. So if we have our kind of standard XY plane here, this is the x-axis, this is the y-axis. We talk about measuring angles from standard position. What we mean is angles are always measured from the positive x-axis. Okay, and we call that side the initial side. Initial means that's where the angle starts. Initial side, okay? And the angle goes counterclockwise until it hits the terminal side. The terminal side could be anywhere in the circle as you kind of go around. It could land anywhere. We'll just put one here just as an example, all right? But the side where the angle ends is called the terminal side. Okay, the terminal side. And that's how we measure angles. So if we wanted to measure a 50-degree angle, then we would measure it starting at the positive x-axis, counterclockwise up to 50 degrees. All right. I do want to label the axes here. So this starts off as, this is 0 degrees. In fact, let's do this in a different color just so you can see clearly here. 0 degrees. And then as we go up, this would be 90 degrees, 180 degrees, and this would be 270 degrees down here. That's something that I would probably jot down, so you've got that in your notes, just kind of where those angles are. Also, this could be then 360, right? If you go all the way around, went all the way around like that, that'd be 360. And you can keep going, as we'll talk about in a minute. You can go 540, you can go 1,000 degrees, you can just keep going around and around and around. Okay? So let's go on to the next slide here. All right, so let's sketch a couple angles. First thing we're going to do then is sketch 110 degrees. So sketching angles are just that, sketches. I don't expect them to be perfect. I don't expect you to use like a protractor or anything like that. We know this is 0 degrees here and 90 degrees up here. So 110 has to be 20 degrees past 90, right? So that's going to be approximately right here. So we'd sketch the angle like this. You need to draw in the terminal side, and you need to draw in this little curve that indicates where the angle is, 110 degrees. Okay. Negative 20 degrees. Let's talk about negative degrees. In fact, I'm going to erase this one, so make sure you jot that down. I'm going to erase this and we'll draw a negative 20. Negative 20. We haven't talked about negative angles yet, but negative angles, instead of going up like this, and those are positive angles that start from the positive x-axis and go clockwise, counterclockwise, excuse me. Negative angles start from the positive x-axis, start from the same spot, and they go counterclockwise. So negative angles start off going down, positive angles start off going up. So if we want negative 20 degrees, that's not very far. Remember, negative 90 would be down here. Right? So negative 20 would be not very far here. Maybe something like that. Okay, so negative 20 degrees would be right there. That's a degree symbol. Okay, so that's how you draw positive and negative angles. Let's talk about coterminal angles. Coterminal angles. Coterminal means, the meaning of that word is terminal, which is ending, okay, and then co means the same. So this means the same ending place. In other words, coterminal angles are angles that start and end at the same place. Let me show you how that could happen. So we have our first angle here is negative 450. Okay, well negative 450 would, let's just draw that in first. So negative 450 would go like this. So there's negative 90, negative 180, negative 270, negative 360, and then add another 90. So that'd be negative 450 right there. Okay, so this angle, negative 450, looks like this. Okay, but negative 450 is the same as negative 90, right? Those start and end in the same place. They both have, this is the initial side and this is the terminal side. Okay, so 450 is the same as negative 90. All right, now we could also continue adding 360 degrees. In other words, we could continue adding full circles to this. So instead of 90, you might notice, and I'll erase this red line here just for clarity, but you might also notice that negative 90, if you started going in the positive direction, this is actually the same as positive 270 degrees. All right, that's the same as positive 270. And you could add another circle again. So you could add, because the only rule is that you start at that positive x-axis and you end on this line here. That's the only rule. So any angle that does that is coterminal. So we could add another 360 degrees and another 360 degrees. Or we could subtract 360 degrees several times. So here are a couple coterminal angles to negative 450, but there's an infinite number of coterminal angles for any angle, because you could just add or subtract full circles continuously. So we're not going to do this last one here, but 3950, if you wanted to know where that landed in the circle, you would just subtract 360 a bunch of times until you got to an angle that fit inside of the circle here. Okay. You could also divide by 360 to get an approximately how many times you would have to go around. Right? Coterminal, starting and ending at the same side. Okay, we're going to shift gears a little bit here and talk about radians. Now, I wouldn't write anything down yet. Okay, I'm going to play a little animation here and then pause it and talk for a second. So you can see right here this blue line, that is the length of the radius of this circle. And right here in the middle is the radian count. Radians are another way to measure angles. There's degrees, but then there's also radians. We're going to talk about radians right now. So we're going to let this go until it's at 1. Try to stop it there. Okay, so at 1 radian. Okay, so this is the angle that is 1 radian. You can see it's at about like, I don't know, 50-ish degrees, maybe a little bit past 50. But 1 radian is the angle created by going around a circle 1 radius. Okay, this distance right here is a radius. The angle that's made is 1 radian. Okay, we're not going to get too much into the definition of radians here, but I do want to show you some important numbers that pop up. If we go halfway around the circle, you can see that it's really close to 3.15, which is close to 3.14159, which is pi. Okay, so halfway around the circle is pi, and then all the way around is 6.25, which is approximately 2 pi. Okay, so it turns out that exactly halfway around the circle is 180 degrees, and all the way around 360 degrees is 2 pi radians. I think I've got that on the next screen here. Yes, so here's your conversion from degrees to radians. 180 degrees is equal to pi radians. Okay? That is something that you've got to have written down somewhere. That is incredibly important. 180 degrees is pi radians. We're going to use that like a conversion like we would anything else. Like if we were converting from miles to feet, it'd be 5,280 feet in 1 mile. Okay, so let me show you how we use that conversion on the next slide here. Okay, if we wanted to convert 1,250 degrees to radians, here's what we would do. We would put 1,250 on a line, so this is 1,250 degrees. Okay, so 1,250 degrees. All right, and we would use our conversion. Pi radians, 180 degrees. I would want to cancel out degrees, so I'm going to put 180 degrees on the bottom and pi radians on top. Okay, so to figure this out, I would simplify this, or I could do it 2 ways. One way is put it right in your calculator, 1250 times pi divided by 180. Another way is just to take these 2 numbers and simplify the fraction and leave the pi in it. Okay, so when you simplify this, you get 125 over 18 times pi radians. Okay, so the units on this are radians. Okay, or if you had just done the decimal, you would have gotten 21.8 radians if you just multiply 1250 times pi divided by 180. Okay, let's skip that example there and let's go on to one where we're converting radians to degrees. So let's take negative pi over 12 and convert it to degrees. The way that we write this out is negative pi over 12. We'll put radians here. And then since we want to cancel out radians, we'll put pi radians on the bottom, and we'll put 180 degrees on top. The radians will go away, the pi's will cancel out, and I'll get 180 divided by 12, which I think is 15, but let's check. By 12, it's 15, so this would be equal to negative 15 degrees. Or you can use the degree symbol, it doesn't matter to me. Okay? And that's it for converting between degrees and radians, and also measuring angles.